Hello and welcome to TidyX, episode 20. Wow, we're already on episode 20. All right, TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes. I work at Fred Hutch Cancer Research Center as a statistical programmer.
And my name is Patrick Ward, and you can find me on Twitter at OSP Patrick, and I do data analysis in sport. And you can hit up both of us with questions at tidy.explained@gmail.com or our Twitter handle at tidy_explained.
All right, like I said, we are already on episode 20, and we're really excited for this one because we have a special guest explainer today. All right, and that guest explainer is David Robinson. So David, do you want to maybe take a second and explain who you are, what you do?
Yeah, thanks for having me. So I'm a principal data scientist at Heap. We're a product analytics company. And I've been working in R for about 10 years and have been blogging pretty actively in R and publishing some open source work for about 5 years. I'm a really big fan of the Tidyverse, and I'm an extremely big fan of the TidyTuesday project. And I've created a couple of open source packages like Broom, co-creating TidyText with Julia Silke, the fuzzy join package, and the widyr package, which I'm really looking forward to talking more about today.
Awesome. All right. And he also runs a weekly Tidy Tuesday screencast. Do you want to explain that for a second too?
Yeah, there was a long time that I wanted to try finding a data set and recording myself, analyzing it for about an hour, show some of the tricks that I use when I'm going through a data set, some of the visualization tricks, the data cleaning steps in the Tidyverse. And the thing that I was missing was a clean data set that I could share, like this analysis process. And then when I learned about the Tidy Tuesday project, which released like a new data set every week, that it was just absolutely perfect. So I've released about 50 screencasts where I record myself for about an hour analyzing a data set without doing any preparation in advance. I show how I jump into the data set and how I go about analyzing it, making some visualizations, drawing some conclusions. For about the last 8 or 9 of them, I've been doing it actually. I used to record them and then post them on YouTube, and these days I've been doing them live, which is really fun because people follow along with them, give some suggestions, ask some questions on a live chat. So I do those every week, Tuesday at 5 p.m. Eastern.
All right. Yeah, I know. I've had a great time watching those, and I've learned a bunch watching those. So thank you for putting those together. All right, so we reached out when we were organizing this and figuring out when David could do this. We asked him to pick a data set that he'd want to go through and explain in some code. And so he picked Tidy Tuesday 2020, week 22, which was the cocktails data set, which I know I had a ton of fun going through that. I made an ML or an AI model that would generate cocktail recipes. So I had a lot of fun working on that. And I know David, his screencast was great, and he posted some great stuff in there. So his code is available here. It's on his GitHub account. And then you can also watch his screencasts on YouTube at his channel. So we pulled the code down into our studio session, which we've got set up here. All right, so we're gonna just hop into it and start explaining it. So David, like we said, just hop in if you want to start explaining a piece here, if we're confused or anything, and let's get going. All right, so
yeah. I'll tell you the fun fact about this one is this is the screencast that actually decided to go with the theme and drink it old fashioned as I was making it. So, that was definitely playing with fire because I hadn't tried coding under the influence before, and it's not something I would do every week. But it was a really fun data set. It was a fun experience. Yeah.
Well, you've heard of the Balmer curve, right?
Yes, the Balmer peak. Yeah,
yes.
You have to get exactly the right amount. Yeah.
All right. So as you can see, this is an R Markdown. So the first thing David does is he puts his YAML there at the top where he's defining the title, which is the title of the document, the author, which is him, and the output. So he's going to be outputting an HTML document. He has a setup bit here, which is a pretty standard R Markdown piece where he's setting his knitter options. So this is setting echo to true. So this, when he knits the document, this will then, when the code gets ran, it'll also show the actual code that was executed, so you can compare the output against the code itself. In this first chunk here, he's loading in all his libraries that he's planning on using. So he's loading tidytuesday, which is a package I wrote. So I'm pretty excited about that one. The tidyverse, which is what everyone these days is using for data manipulation, and scales, which provides tools for the manipulation of the dates or values for plotting, and some various other tools as well.
Yeah, I'll tell you, I found that every week I need to load the scales package at some point because I almost always have a percentage on a y-axis.
Mm-hmm. Yeah, and so it has a nice scaling of percentages for you, so you can just drop in a decimal value and it'll scale that for you. And then there's the theme set. So this is where he's setting the theme for the rest of the R Markdown. He's using the theme light package, or theme light theme, to be doing that.
I got that idea from my old coworker Julia Silke. Always use theme light, and I end up I do like it more than the default ggplot2 thing.
Yeah, and we do the same thing. Longtime listeners will know that we do that exact same thing on our processing. All right, so let me run that. So I always forget to run it as I explain it. All right, so here you're loading in the data from TidyTuesday. All right, so it's downloaded, and now we run this. So this then brings up the R Markdown, which you're able to then go through as you're working through your code and the data to see what was going on with that. So I mean, I thought that was really valuable when I put that together, and I'm glad to see that it looks like you do as well.
Really cool.
So next you're going to be pulling the Boston cocktails out of the TidyData object, which is from TidyTuesday, and assigning it to Mr. Boston. So that way you can use it and manipulate it later on a little bit more easily rather than trying to access the full object. So here you're using count. So count is a function that you can, you pass a data set, the name of a column, and it'll count the different types of records that exist within it and return a tibble, I believe. Yes, that shows the name. So in this case, this is name, which is the name of the cocktail, and N, which the number of rows in the data set are the number of ingredients that exist. So like Academic Review has 6. So it looks like a number of these cocktails have 6 ingredients in them. Patrick, do you want to maybe take us through this next chunk here?
Yeah, so you go on and do a bunch of visualizations here. Anybody who's ever watched David's screencasts, which I think they're excellent, and I always learn a ton from them. He sort of follows this consistent stream of learning the data where he loads it in and visualizes some things and realizes what needs to be cleaned or changed or adjusted, and then he does that and visualizes a little more and then builds a model, ultimately covering a lot of ground in 60 minutes. And so this is kind of his exploratory portion of the script. So here he's taking the count of ingredients, and this is a method that he uses a lot. He puts them onto a bar plot using geom_call. So it's a side flips the x-axis so that everything is kind of going horizontally across the page, and it makes it easy to read the variables on that x-axis, which is now the y-axis. So what he's doing here is he's counting the ingredients. He's going to select out only the top 20. I think there will be several hundred rows, so he just wants the ones that are most prevalent within the data set. The mutate function is he's setting the ingredient using FCT reorder, which is basically saying reorder ingredients by column N. And column N, as we saw in the tibble above, is just the count column. So he's saying reorder ingredient by column N, and then he's doing a ggplot. So the plot is actually going to come out in that reordered way based on highest to lowest. And geom_call tells it that we want a column plot, and then he puts a title on that so that we know what we're looking at.
Yeah,
I'll tell you, I absolutely love this kind of plot. I make this plot basically every week.
Yeah.
That combination of count, FCT reorder, geom_call. Actually, I gave a talk at the DCR conference last year, where I introduced 10 tremendous tricks in the tidyverse, and this covers something like 3 of those tricks, like and, bar plot with the horizontal bar plots like that. Like I think this is the way that I start getting familiar with the data set, orienting myself in a data set. Yeah.
it's just a great way to understand like what you're looking at exactly. So this is, gin is the most common ingredient that you're going to be finding across Mr. Boston Recipe. So it's a very gin heavy book. I don't know if you like gin. I've developed a taste for it.
I like gin.
So then you have this end distinct function here, which is going to calculate the number of distinct values in the Mr. Boston name. So this name of the cocktail, so this number of recipes. So there are 989 different types of cocktails that exist in the data set. So here's a little bit more intense of a manipulation. David, do you want to take us through this?
Sure, yeah. So after I saw this ingredients, I realized that I was kind of curious. I was curious about categories of drinks. There's a category column as well. And I thought about the fact that, say, classic cocktails, I think, are more likely to have something like gin in them. And then you have other, it's been a couple weeks, but there were other couple types of categories. And I wondered, could I create a stacked bar plot that communicated not just the frequency of the ingredient, but what types of drinks they tended to appear in? And to do this, I really needed this trick, FCT lump, which is another one of my go-to tricks. From the forecast package. An FCT lump will take this will keep only the 4 most common categories, put everything else into an other category. And notice actually, I do a filter ingredient not equal to other. I think in the original screencast I had to take an iteration or 2 to get to. The reason is you can't do head 20 anymore because you've counted not just at the ingredient level, but at the category level. So I needed to say, what are the 20 most common ingredients? But I couldn't the counted result was no longer 1 row per category per ingredient. It was 1 row per ingredient in category. Actually, if you try running it up to the mutate, you can see what the outcome is. Yeah, so notice like now it's got 1 row for each category and ingredient, and I can't just say what are the top 20. I could be dropping part of gin or part of vodka. So this like FCT lump with filter is kind of another neat trick. Yeah. Yeah. The last note here is that I do n divided by n recipes because I wanted to show a percentage of all recipes, not just a number.
And then it looks like here you're using the percent format, which is from the beautiful scales package.
This notice, like I decided at this point, because I liked this graph, that I'd put a little more work into polishing it. That's something I do both in the screencast and in my regular work. Is like, I see something, okay, I understand it, I'll move on. But then if I like it, if there's a kind of graph I might share on Twitter or on Slack with a coworker, that's when I start polishing it, adding labels, making sure the axis has the percentage sign and so on. Yeah. And this graph I like how Cocktail Classics just dominates in gin.
There you go. Yeah. Solgent and dry vermouth. That definitely shows up a lot in classic cocktails. So that's a fun way to go look through your data. If you have a lot of categories, but you only really care about a couple of the top ones, FCT lump is super useful to like, okay, I only care about four categories. The rest of them, they're too small to actually care, or not necessarily not to care about, but it'll dilute the actual product that I'm trying to put out, which is this plot here with having a ton of different categories. So let's lump them together into the other. Cool. So we've got that plot together. So now you start onto the next step here, which is you labeled this as primary versus secondary ingredients.
Oh, this was an adventure. This was such an adventure, and the bourbon was starting to kick in. So, maybe I don't know if one of you wants to walk through what I'm doing here, but yeah.
Sure. I mean, we can take a stab at that and let us know if we're getting way off base for what you were thinking. But first, you do a count on measure, which will give us the different types of measures that exist. Because when you're making cocktails, you don't just like pour it all into a cup. You should measure it. That's how you know it's going to be good. So you look at the different types of measures. So you've got like 1 ounce, 1.5 ounces, 2 ounces. So these are the proportion or the amount of each type of ingredient that's supposed to be going into that. And so it looks like what you're going to want to be doing is you take the Mr. Boston data set, you use the extract function from, I believe that's from tidyr. You pass the measure column to it and go, okay, I want to create this new column called amount. I'm going to use this regular expression, which can get a little bit confusing, but what you're trying to do here is you're extracting the string before the space ounce inside of measure. So if we look at this here, if you were to apply this regular expression to this columns in measure, so this would extract the 1 because you've defined that group that you want to be keeping, then the 1.5 ounces because this is basically what it's going to be lopping off, what I'm highlighting here every time. So that's what it's generating there, and remove equals false because by default I believe it'll try to remove that measure column, and we don't want to do that. So we're just wanting to add amount to the data set. Then you apply the same idea with, now that you've generated this amount, you're like, okay, how do I break it out, because we've got the 1.25 ounces, 3 ounces, we need to be able to separate that and make actual numbers that we can use for analysis for this. So you extract the ones, which are like the 1, the 2, and only keep those. So you're specifically using this regular expression to pull those out. And convert equals true, I'm guessing we'll convert those into numeric values, or whatever they are.
It's very powerful extract, yeah.
Yeah, and then you have the extract amount on, and this time you have 2 different columns you're trying to output to, and this is numerator and denominator. So we're trying to pull out the 1/2 ounce, the 3/4 ounce, and turn those into actual values that you can use as well. So you pull all those out. So this is defining that first group that you're going to want to be keeping with the parentheses. This is defining the second group you're wanting to keep with the parentheses. And this is now you get numerator and denominator. You're going to be replacing cases in the ones column if it's NA with 0, numerator with 0, and denominator with 1. That way we don't end up with trying to divide by 0, which of course we know works very well. So then you're calculating the number of ounces for each measurement or for each ingredient by adding them all together. This is dividing the numerator and denominator, so you get 0.75 as opposed to 3/4. And then replacing any 0 or any NAs with 0 with this last NAF. So then you use that to generate your Mr. Boston parsed data set.
Yeah, I'll tell you, this thing, I've never done this before, trying to parse out totals and fractions from a from a string. This was definitely one approach. One thing I liked about it is that it keeps all the intermediate steps, so I was able to debug as I went. I was able to say, oh, is this, like, I was able to check, for example, that 1.5 turns into 1.5, or that 1/4 turns into 0.25.
Yeah, that's a pretty tricky way. Yeah, when I was looking at dealing with the ingredient measurements, I was just flabbergasted. I have no idea what to do here, but you came up with a pretty great way under pressure.
Yeah, under pressure and under the influence. But the other thing I note there is, like, I think regular expressions really are worth the effort to spend some time to get familiar with. Those there in line 63 and 65. What I'm doing is saying, like, if the and then line 63, I'm saying if the full \\d plus means digits. So it says start any number of digits end, that goes the caret digits end, or start digits space. That's how I got out the ones.
Okay. Wow.
Yeah, that would be how I'd say, okay, I need it to be either fully digits or digits and then a space. Think about how much processing is happening right there. Like, if I'd done that in a bunch of ifs or case whens, it would have taken a good deal more effort.
Yeah.
A regular expression could be really powerful for that.
Incredibly powerful. Patrick, do you want to take us through this next bit here?
Yep. So then you're taking that Mr. Boston parse data set, grouping by name, and then you're creating a percentile by subtracting the row number of each of those rows, each of the variables or names within the rows, and dividing by the total. Then you group by again, this time by ingredient, and you're doing a summarize. So you're going to create a new data frame, which you'll call ingredient summarized. N is just going to give you a count. So that's just basically the sample size that you have. N with ounces is going to be looks like sum is not in a ounces. So basically counting up the number of ounces for each of the ingredient. Average position is going to be your mean percentile. Okay.
I'm really curious, did an ingredient tend to come first in a drink or last in a drink? That was what I was trying to say.
That was the percentile. Yeah. Okay.
Percentile will be like point. Let me see, what would it be? It would be like 1 out of 6 if it were the first of 6 ingredients.
Yeah.
It would be 1 if it were the last of 6 ingredients.
And then the average serving size is the average serving size of that ingredient within the drinks. And then you're arranging by descending n, so highest to lowest.
I almost always try, after a summarize, I like to descend by the frequency of each item because every data set's going to have some junk ingredients that maybe happen exactly once. And I want to focus on the things that pop up the most. Yeah.
Yeah.
Exactly. That's reasonable. So we end up with this tibble here where gin is used 176 times. Never is it not measured. And it's usually positioned, so 0.57. So it's usually positioned a little after halfway through the order of the ingredients there, and the average serving is just over 1.25 ounces of gin. So a good serving of gin every time, which sounds like a great plan. All right, so now you're loading. So you loaded. I think this is probably an artifact of the fact that you're working through it and you're figuring it out as you go. So you're loading GG Repel in here at this point, which is a library for allowing you to use this geom text repel, which will allow you to draw labels, but you don't have to worry about them overlapping. So you.
Yeah, I probably in this graph I can't remember, but I probably first made a geom text, and then when I saw a lot of the text was overlapping each other, jumped to geom text repel. Yeah.
So what you're doing is you're taking the top 30 ingredients that are listed here from ingredients summarized, since we've already ordered that. You're sending it into ggplot, where the x-axis is the average position of the beverage or the ingredient. The y-axis is the average amount that they're serving you. This is assuming they're all ounces too.
I think I did measure it. I made sure they always had the letters OZ in them.
Okay.
But there's data cleanness here.
Yeah.
You might point out, yes.
Yeah. Geom point, so you're also now defining the size of that point to be the ratio between the number, the n, which is the number of times the ingredient is used divided by the number of recipes. I'm trying to remember what n stands for there.
Yeah, it's a percentage. That'd be like the number of drinks that appears in divided by the total number of recipes.
Yeah.
It's like 10% of recipes, 2% of recipes.
Yeah. All right, then you're setting the geom text repel to the label. You're adding a label, and it's going to be the ingredient of that label. You're scaling the x-axis labels by percent, and same with the y, or the size. And then you're making it pretty by saying the y, x, and size. You're defining what those are. So average serving size, average position within the drink, and percent of recipes. Oh, there we go. Sometimes it doesn't like it when I have my viewer over here. So there is the next plot that David made, where you can see bourbon whiskey isn't used, or it's used pretty early on in the beverages that it's used on, and the serving size is pretty large. So if you like bourbon, go to Mr. Boston or gin here. Though I think it's also interesting that they differentiate old Mr. Boston dry gin from gin, and I think that happens fairly often as they use brand names in the data set.
Yeah, it's definitely something that I could have spent time to clean up. For example, you see juice of a lime pop up there, and I think you see fresh lime juice appear somewhere else. Lemon juice, fresh lemon juice.
Yeah.
I don't think anyone's really saying, well, you got to add some lemon juice, make sure it's not fresh.
I want that old stuff that's been sitting in your fridge for the last.
The other thing I like about this this kind of plot is it combines a lot of data. So even though it's an XY, two-dimensional plot, you have that third dimension where the size of the dots are actually changing by the recipe percent of recipes that the ingredient is in. So you do get a sense kind of for just the sample size of each of the ingredients within the data set, which is really nice.
Oh yeah, and I didn't even use up all the aesthetics we could have. If we had another thing we wanted to communicate, we could have used color.
Yeah, or shape maybe.
Shape for something that has relatively few discrete categories.
Yeah, that's the only problem, right? Yeah.
So yeah, if you wanted to do like an FCT lump of like the recipe type, like the classic cocktails or.
But that doesn't that you couldn't necessarily have gotten under here because each ingredient type doesn't have one category.
Yeah,
common category.
Yeah, it would have to been done by the most common category.
Yeah, but what I really get from this is that top left is like 5 kind of what you call primary ingredients, things that are always at the start and among the heaviest like servings. Yeah. I also find up here which is that there's no way anyone's adding an ounce and a half of Angostura or orange. That's a data problem.
Yeah. Could have been meant to be a dash. Hopefully it's supposed to be a dash or two, unless you really like bitters, which no judgment. Mm-hmm. All right. So now you're gonna take it through. You do a couple more plots here. So you filter to keep cases where n, so the cases where it's listed more than 10 times, and also do a geom point against the average serving that it has. You scale the x-axis by log 10 because I'm assuming a couple of them were just used basically constantly at a very high amount, and you wanted to be able to scale it down so that the ingredients that are only used like 3 or 4 times could still be seen in that axis. There, you use geom text to label those ingredients again. You have it checking for overlap, and you
check overlap is kind of like the geom text repel, but when you have way too many points, the geom text repel would be like here. If I'd used geom text repel, it would have looked like a mess.
So there you go. So and then you also, so I jumped ahead of myself. VJust and HJust are adjusting these to always be down and to the left. Of the point there, and then expand limits. You only set 0 because then that's going to tell ggplot to cut it off at 0 and not try to plot some stuff that's further past 0, because none of these should be less than 0.
In this case, the main thing was to keep 0 in the axis, because otherwise the minimum would have been something like 0.3.
Gotcha. Interesting.
Yeah.
So you can see here, gin is used the most frequently, vodka. So it's another way to view the same data set there. And then you do this next one. Do you want to take us through this one?
Yeah, this was another way of looking at the same data. There's a first where I tried to combine kind of everything, the where it occurred. Here I just was interested in what are the largest average serving sizes. So I said only only drinks only drinks that appear in at least 10 recipes. What are the 12 largest ones? So arranged by descending average serving, had 12 the 12 largest, and then everything. The next 3 lines are just another one of our reordered geom calls, horizontal geom calls. So if you show that, it's gonna. That's if I want to focus on this rather than on any of the other dimensions. We really see that. Did I filter out the bitters somewhere? It's good because the bitters don't pop up there. Did I filter out the bitters? I don't know where the bitters are. No, I don't see them.
I don't know.
Well, maybe that's why I had 12 to avoid those. But yeah, I see that like juices and whiskeys are the 2 things that you add a lot of. The top 8, it goes juices, then the whiskeys, then some rum and a few other things.
Interesting.
Yeah.
So beverages with whiskey in it tend to be mostly whiskey, or have a lot of whiskey in them.
Yes, yeah, this is the way I like it too. So and we can see again there's data clean issues where orange juice and orange lowercase j both appear at the top and the bottom.
Yeah.
That one, where I really could have spent a little more time cleaning it. Yeah.
Mm-hmm. But you go through a lot in an hour, so
it's an hour-long show. It's an hour-long show.
All right, so then you start getting into clustering, and here's where we see widyr.
I'm so excited about this because I've used the widyr package in a good number of screencasts. I kind of speed through it. A question I have for the 2 of you is how much have you used the reshape package, the reshape 2 package, I should say?
I use it all. I used to use it all the time until I finally decided to learn pivot wider and longer. But I used to use reshape 2 all the time.
Yeah, I used before I jumped onto the tidyverse, I used reshape a fair amount and reshape 2 a fair amount. I got super used to the spread and gather. I get why people didn't understand it, but I'm still kind of on the spread and gather mindset. I'm figuring out pivot wider and pivot longer.
So I reshape 2 for people that are newer to R was kind of proto tidyverse. It was one of Hadley Wickham's packages that he developed before packages like dplyr and tidyr, and it had some tools in it for reshaping columns into rows, rows into columns. They were kind of early drafts of what would become spread and gather and pivot longer, pivot wider. But what there is still a functionality that I still have sometimes gone to, that I kept going to Reshape 2 for, and that was creating matrices instead of tables. You don't see a lot of matrices in the tidyverse. They're mostly focused on tables, but there's some things that you really need, that you actually do need to work with matrices rather than working with a table. And one of them is correlations. So I don't know if anybody wants to walk through this or if I should walk through this, but
take us through this. Show us, educate us.
Yes. So so far I've been working with groups of ingredients, groups of categories, summarizing those groups. These are all tools that dplyr is really, really well suited for. But I want to do something else. I wanted to compare one ingredient to another. I want to say, how often does gin appear with lime juice? How often does whiskey appear with rum? I wanted to compare it between groups. And having the data in that tidy form, one observation for each per recipe, per ingredient, is not a good shape to do that. You really, generally, you would want it shaped in a matrix where each row is one recipe, each column is one ingredient. And I really didn't like that that took you out of the, that takes you out of the flow of the tidyverse. That reshaping, saying, I've been working with a table so far, I've been using dplyr, now I've got to switch to a matrix, do some things to the matrix, and now that it's a matrix, I can't put it into ggplot2, I can't do anything with it. That always bothered me. And that's why I developed a couple of years ago the widyr package and Pairwise core. So I'm going to walk through what I do in these 3 steps. Mr. Boston, I add count ingredient. That's a dplyr function that will, if you just run that one thing, that just adds an n column that will say how many times does that ingredient show up. So I know that light rum appears 113 times, but passion fruit only appears about 4 times, so I can remove that. Or passion fruit, then that tilde. So then I throw in filter n greater than or equal to 10. That's just making sure I don't include any of the really rare ingredient, like it'll move apple schnapps from the 9th line. But the important thing I do then is I do pairwise correlation. I want to say I want correlations between ingredients, so between light rum and bourbon whiskey, and between every pair. That's why it's called pairwise. And how am I comparing them? The question is, do they appear in the same name? So name would be is the recipe column. So how often do they appear in the same recipe? And does it appear more often together than you'd expect by chance? And the third is I say I want to sort them in descending order. Oops, I have to fix the widyr package. I think that may have been fixed in GitHub, but not in CRAN.
Yeah, I installed from CRAN, so.
Yeah, that could be the story. But sorry about that. That's definitely on me. But the story is, what we get from this is pairs of ingredients. And remember that we were always working with 1 row per recipe per ingredient. Now the recipes are gone. It's just pairs of ingredients, which we call item 1 and item 2. And we see that, in fact, juice of a lemon and powdered sugar always appear together, and it's symmetrical. Juice of a lemon appears with powdered sugar appears with juice of a lemon, and they have a correlation of 0.46. So that's a Pearson correlation of binary data. It's also called a phi coefficient. It's a way of saying these two appear a lot more often together than you would expect by chance. And then the same with brandy and half and halves. Also, coffee flavored brandy half and half sounds yummy. Sugar and egg.
Okay.
So basically, under the hood, is it just building like a whole bunch of matrices of 2x2 tables for each of these variables to calculate the phi correlation?
No, it's creating one matrix. So actually, I don't know if you ever go to other pages while you're explaining these, but if you went to the widyr README, you can see a diagram that shows what widyr is doing under the hood.
Oh yeah, that'd be cool.
I can bring that up. Going through the Google. There you go.
Cool. So scroll down a little bit, and nope, I might have lied. Let's go back up. There wasn't a figure in there.
Negatory.
Oh, never mind. Man, I really thought I'd put in the figure. Check the vignettes folder real quick. Like just the. Nope, never mind. All right, ignore that. I had a figure. Oh, that's embarrassing. All right.
Oh well.
Oh well.
What it's doing is it turns this tidy data into a matrix that has one row for each recipe and one column for each ingredient. Then it performs correlation on that matrix.
Oh, okay. Yeah. I see.
Correlation on a matrix is a very fast mathematical operation.
Yeah.
And then it turns it back into a table. But because you're exactly right, like otherwise you kind of have to get this pair of ingredients.
Yeah.
This pair of ingredients, do something like this. This can actually work because it works on sparse matrices. It can actually be a rather large data set. You can find correlations among them. Yeah.
Awesome.
So how long did it take you to for a function like that, for you to sort it out in your head how it was going to work? Like how long would it take you to write something like that?
Oh yeah, I wrote that widyr package in 2016, and the reason I wrote it is I've been solving the problem again and again in the same way, which is turn into a matrix, perform a correlation, turn that correlation matrix back into a tidy table, and I was definitely getting sick of doing that. So at that point, it was relatively fast to say, okay, well, I'm going to take those steps, turn them into a couple functions. Mm-hmm. Pairwise Core isn't the only function it provides. Later in this screencast, we'll see another one called widely SVD. But it, I don't know, it took probably a couple of weeks of maybe tens of hours of development over a bit of time, writing some unit tests. The hard part isn't writing the original function. The hard part is making sure it'll work, maintaining it as different people find different kinds of bugs.
Yeah.
But that's I think where packages can be really powerful is that I don't have to worry if I were walking through this code, it otherwise would have taken a lot of steps. I would have had to explain everyone and how it works. And in a particular data set, it might work differently than another. And the code turns that all into one convenient package.
Yeah.
There you go.
Yeah.
Super nice.
Cool. Yeah.
All right.
Love it.
So all right. So next, what you do is you go through and you keep only the cases that are gin, tequila, absinthe, mezcal, bourbon, whiskey, and vodka, and you do a group by on those items so that you can pull out the top 10 correlations of each one of those. So you're going to filter them. So the second item can be any one of the several hundred different ingredients that exist, and you're going to keep only the top 10 for each one of these 6 there, and then you're going to mutate and do a reorder within to then reorder within the item 2. So reorder item 2 by correlation within item 1, so that you've is that?
Yeah, reorder within is a function from TidyX that solves a problem. It solves a problem that used to happen if you want to show a faceted graph where each facet has a different ordering. Mm-hmm. It has a sister function there, scale y reordered, on line 147. Those two, you always see one of those with the other, mm-hmm. Or scale x reordered. It's you'll see that it creates a really pretty faceted graph where each facet has its own ordering.
Yeah. And then what you do is you go send it through this, there we go, through the ggplot. You say your x-axis is correlation, y-axis is item 2. You add your geom call, so you make the bar plots, and you add this facet wrap, and that's what creates the different panels. And you're saying, okay, now facet by item 1. Scales, so you're saying, okay, scales free y. So this is saying your y-axis will be free so that it can scale up and down to whatever it needs to be. You're saying scale y reordered, so this is based on this, so that'll allow you to reorder within the panels. And then you're adding the nice title, what ingredients are most correlated with particular ingredients. So let's rerun that. And my computer is struggle busing apparently. So that's
like the Zoom or
Zoom.
Yeah, that's what I was gonna do. There we go, Zoom. Nope. Maybe it's my RStudio install. I apologize for that.
Might be your screen resolution. You know what you could do is you could reduce the number of you could make it just two
there we go.
Or yeah. I thought it's supposed to be 6 ingredients, aren't there?
There should be.
Did I misspell some of them? That seems odd. Maybe I did. Or maybe it's only showing part of the graph. No, it doesn't seem right.
It's got the correct scaling on the Y.
I think maybe it I wouldn't worry about it. Maybe I misspelled something, mescal or something like that. Or I actually think that mescal and absinthe didn't make it into they didn't appear in 10 recipes is probably the reason.
Oh,
I think I just moved on at that point. Yeah.
Right.
There you
But
go.
the story here was that I had made a graph for whiskey, I'd made a graph for gin, and often when I make graphs one at a time, I want to then use the power of faceting to show a couple of them, show as many conclusions as I can within one visualization.
Mm-hmm.
Yeah, that's great.
So like bourbon is often is highly correlated with fresh lime juice or lemon juice, Angostura, simple syrup, orange bitters. So those are an old fashioned. I'm kind of seeing a little bit right there.
And well, fresh lemon juice, what, like a whiskey smash, like
Yeah.
or a couple, definitely like the bitters and the syrup, and don't surprise me at all. But yeah,
Mm-hmm. And then vodka with the.
What bourbon and triple sec? I don't even know.
I'd have to, if I had to guess, I'd say Long Island iced tea.
Yeah. Gin and vermouth are a classic combo because that's a martini.
Oh, for sure.
Martini, sure.
And then the egg white, juice of a lemon. I can see that with like a gin fizz or something.
I still don't understand the egg white. Who's ever doing that?
Oh, gin and egg white, it's very refreshing.
Yeah,
like,
you shake it up and it becomes like a fizz.
Really?
It's super good.
Oh wow, no, I never. Okay, interesting.
Okay, whenever we're out of quarantine, Patrick, I'll take you to a bar and we'll get some of those.
I just drink straight whiskey. Neat. Give me a neat. Pretty good.
And then vodka.
I use a screwdriver.
Oh yes.
Oh yeah, there you go. Yeah.
So everyone knows that one.
Vodka cranberry super popular.
Yeah.
Yeah, that's the suburban teenager drink of choice. Yeah.
I guess I'm kind of surprised there's no. What is a Bloody Mary? Vodka tomato juice?
That's true. I don't see Bloody Mary. Maybe there are more variations on a screwdriver than there are on a.
Maybe.
Bloody Mary.
That'd have to be. Yeah, because it's the number of times it appears, right? Not
maybe it might also not have passed the cutoff of number of recipes. Yeah. The story there was looking at what tend to appear together by chance. Yeah.
Mm-hmm.
Yeah.
All right. So now it looks like you look into the correlations a little bit more. You use gggraph and igraph that are providing tools for providing node comparisons here. You're going to keep the top 150 pairs there. You're going to do a summarize, so filter to make sure to keep all the cases where you have the top 150 ingredients.
There's like the top 150 pairs. So I want to node information on them so I could size the points based on their the number of drinks they appeared at.
Mm-hmm. And then,
right. You can see that from the graph and data frame vertices.
Yeah.
I think gggraph is just as widyr brings correlations into the tidyverse. gggraph is like incredible at bringing network graphs into the tidyverse. It used to be much harder to create attractive network graphs.
Yeah.
We don't do them with the grammar of graph. It's just so powerful.
Exactly. It's so quick. So it takes the top cores data set here, which is item, and correlation. It's then going to create a graph from the data frame there, where it uses ingredient info, which is defined here. So ingredient and number of ounces, average position, and sets the vertices based off of that. You create the gggraph with the layout FR. I forget what FR stands for. Free.
No. I would too.
Okay. Draw the edge links between them. Create a node text where the label is the name of the ingredient, and repel that. You set the size of the point to be 1.1 times n.
So that's actually, those two lines are like an old trick I use, which is when I have colored points. Do you want to make the graph and then describe it on?
Yeah, that might make more sense.
The story is when you're coloring points, a white point will be invisible unless you put a slightly bigger point under it. A slightly bigger black point under it. So line 168 is a way to set up line 169. Like if you comment that line out, there's going to be some not great. Go ahead and zoom in.
Oh, apple brandy.
For example, or old Boston, Mr. Boston triple sec on the lower right. Like it looks like the point is missing. And the story is, no, it's just at about 50%. Like the color there is white. So if I put that back in, now it gets a black point under it that you could even actually try zooming in. It's not an exact science here. but maybe you need more than 1.1 times that.
Maybe it's just my plot. Apparently, my computer's having difficulties plotting today.
Well, in any case, that's what that extra line is. It's a little bit of a
Gotcha. Yeah. And then you're going to scale the colors from low to high, where the lowest color is red, the highest color is blue, midpoint is 0.5, and set the label scales to be a scales percent format again. And then you define your sizing there. All right, so that is the clustering that you did, and now you jumped over to PCA.
Yeah, zooming on this graph, I really love networks on correlations, because they're a way of turning these ingredients, which right now are like just hundreds of ingredients floating out there. You can look at one, you can look at the next. It puts them in a natural space. It says here are the constellations of ingredients. Note that it's not the 2 points here, if they're not connected, then their distance doesn't mean anything. So like the fact that apple flavored brandy and apple brandy are near green chartreuse, that doesn't mean anything. They're not connected. Mm-hmm. But we do see clusters here. You see like juice of a lemon, powdered sugar, whole egg, as a kind of like refreshing, what do you call it, fizz drinks. And then you see like on the top left, you have like the universe of like vodka and brandy drinks. Which is then connected to a universe of citrus drinks. Citrus, so yeah. And in the meantime, we're adding a little more information with the red versus blue. Red meaning it's a primary ingredient, blue meaning it's added later in the drink. Later in the recipe, I should say.
Yeah. Gotcha. Yeah, it's a great way to show multiple dimensions all at once.
I really like the network plots. Yeah.
Yeah. Cool. All right. So now we jump over to PCA. So now you go through and take the same Mr. Boston data set. Out of that, you do a distinct to keep only distinct ingredients and names, so there's no duplicates that exist. You create a mutate value equals 1. So this is now going to add a 1 to, I'll just run that to show you what it looks like. So now it's just adding a 1 to the column value for all of those. And I'm guessing this is because when you're doing this widely SVD, you need some value to be based off of.
Yeah. So widely SVD is another widyr function, and it's one that, unlike pairwise correlations, it's no longer saying I want pairs of ingredients, I want pairs of recipes. It's not looking at pairs. It's looking at it's trying to reduce the dimensionality of this space. So you two use singular value decomposition or PCA, like principal component analysis, that much in your work?
I do, yeah, all the time, a lot, yeah. Mm-hmm.
Yeah.
I expect so, yeah.
Yeah.
And in healthcare, you run into it a lot?
I don't run into it. I do a lot of the data cleaning. I work with statisticians. Yeah. I don't do the statistics myself. Gotcha. So I mean, I don't know.
I'll tell you that Daniela Whittem had recently, when she was running I think it's Women in Machine Learning and Data Science Twitter account, just this week, had an amazing thread about singular value decomposition.
Yes.
I've been working with SV for a long time, so I was a graduate student, but I learned a lot from the thread, and it's funny, it's informative, it's funny sometimes, and it's I just can't recommend it enough. I hope you have a chance to put it in the show notes.
Oh yeah, definitely will.
But the story is, what it does is I know that every drink has its own recipe, but there's also types of drinks. I could say, okay, maybe there's drinks that are more on the sour side, drinks that are more on the sweet side. Maybe there's drinks that are more on the, like, what we call spirit forward, very strong side. Maybe there are drinks that are on the light and refreshing side. And I wondered, what are the dimensions of that space? Like, what is the most important dimension? What is the second most important dimension? And SVD is a way of a quantitative way of calculating that.
Gotcha. Okay. Interesting. So you calculate SVD, so now you get a dimension where it's sorry, I zoomed out. I'll zoom back in. It's ingredient, the dimension, and the value in that dimension.
Yeah, so there are going to be as many dimensions as there are recipe. Hold on, let me remind myself. As many dimensions as there are. I actually can't remember. Is it as many dimensions as there are ingredients, or as many dimensions as there are recipes? I think I'm pretty confident there are as many as there are recipes. But and then one row within each of those, you can check that. But yeah. and you can check, and then check on ingredient SVD dimension.
Right, so in dim.
No, you'll need length unique of ingredient SVD dimension. But I'm pretty sure it's going to be as many as there are recipes. So length unique ingredient SVD $ dimension. Yeah. I don't. Yeah. Oh, okay. No, then it was as many as there are. As many as there are ingredients. Great.
There you go.
And the story here then is that it's going to sort where the first dimension is the most important in terms of variation, in terms of sorting types of drinks. However, this is me cheating a little bit because I always get mixed up in this. The first dimension ends up being mostly representing the frequency of the ingredient. It's the second to fifth dimension that represent types of drinks. There's a way to fix it that I always forget, and I end up cheating by skipping the fifth. Something I think you can center the ingredients in the recipes, but I'm not going to get it right now. So
yeah. It's all good. So you go through, you have this SVD matrix or data frame now. You're going to filter to remove the dimension that is less, so the first dimension and anything that is greater than the fifth dimension. Do mutate, so now you're adding PC to dimension, so now they're going to be labeled as PC dimension. You're going to group by that dimension and keep only the top N. So this is within each dimension. So you're going to only keep the top 16 ingredients based off of the absolute value. You'll do a mutate to reorder within. So we're seeing that again. The reorder within, reorder the ingredients by the value for each dimension. Create a ggplot where the x-axis is value, y-axis is fill, or ingredient, excuse me. Fill is based off of, is the value greater than 0? So you're doing a binary fill based off that. Set your GM calls, do not show the legend. Scale Y reordered, so that way it reorders within each facet. Adding your facet where each facet is based off the dimension. And adding nice little labels for X, Y, and title. So here we go. Here is the actual plot. And
I can't see it. Am I frozen?
You were frozen for a second. Patrick looks a little bit frozen too, so I think it was my internet that decided to have a struggle moment there. Patrick is still a little bit frozen. But here you can see the different PCs, 2 through 5. Gin is the major driver in PC2. Powdered sugar. So these look like a lot of the supporting ingredients in PC3, like powdered sugar, juice of a lemon.
And notice the other dimension. The other side of it is gin and dry vermouth. So as well as sweet vermouth. So you're looking there at the. It looks like Patrick might have dropped out.
Yeah.
You're looking there. That's martini and the related drinks. Gin, dry vermouth, sweet vermouth. So not as well as so you also see gin and sweet vermouth in a Negroni, So what this is saying is your first type of dimension is your gin and dry vermouth versus your sweet citrusy drinks, your simple syrup, lemon and lime juice. That's the most important variation across recipes. Gotcha. And then you have your variation. You have your third variation. Yeah.
Gotcha. Interesting. Cool. So yeah, this is a great way to show your PCs, and this is a different way that I'm used to seeing PCs, because I'm used to just seeing PC1, PC2, and those two plotted against each other, and you're doing dots across those. So I like this way of showing it. It's a very good way to show the differences between the two.
Oh yeah, you could absolutely also do a scatter plot with some geom text repel, something like that for some ingredients. I do like this in terms of if I needed to give a description to each principal component interpretation, this is the way I usually do it. Yeah.
All right. Cool. So there's that. It looks like you do a few more things where you're. Did this just get duplicated?
Actually, this one is on recipes. So the only difference there is I use Wiley SVD on the recipes, the name, the recipe, instead of on the ingredient.
So this will tell us which drinks are most closely related to each other.
Yeah, what's the most extreme recipes? Yeah.
There we go. So, yeah.
The gin fizzes versus the fizzes versus the punches. You heard it here first.
Let's go.
Experience. Yeah.
The New Orleans Gin Fizz is very, very different, apparently, than everyone else.
Well, it's very different than a punch. Yeah.
Yes. Oh, yeah.
And next is the fizzes and the sours. Yeah.
And cocktails versus... Oh, but these are all cocktails, too. I don't know. That's fun. I like this.
Yeah, I think that the fifth one might be like classic cocktails versus. I'm not sure what I haven't heard of almost any of these drinks instead of say gimlet. But yeah, This is looking at like one of the most extreme types of cocktails. It's showing that like you can use singular value decomposition or PCA to look at to look either at like what are the extremes of source of variation in recipes or in ingredients or in recipes. Yeah.
All right. Well, cool. Well, that was a lot of fun to go through your code and have the actual author there explaining what his thought process was as he was going through it. We're now just gonna, have a conversation and chat for a little bit here. So all right, my camera's going. I'm running. All right. So David, so your background, it looks like it's in quantitative and computational biology, right? Is that right?
Yeah.
So what was your PhD about? Like, what did you work on,
Absolutely.
and what brought you to this world?
Yeah, absolutely. So my PhD was in genomics, especially gene expression, and you work a lot with matrices in gene expression. In fact, I was working with yeast, and I was in our lab. We were very interested in how can we tell what genes are turned on and which are turned off in yeast. It's very important in molecular biology to recognize. To discover those kinds of things, whether genes turn on or turn off, whether they express RNA or not, is really a way that cells can regulate themselves. But honestly, I was sort of doing a PhD in data science before data science was a thing. To me, what was most exciting was that someone would give me a data set and I'd try and learn what I could from it, and I'd try and build tools for better being able to work with the data and learn from it. So I think what I loved is I worked with statisticians. My advisor was a statistician, so I learned a lot of stats from very smart people. But I also got to spend every day working in R, and especially being in bioinformatics, I learned a lot about working with messy data sets. Everything in biology, you'll always get data sets from people that really need a good amount of work to get anything out of them. And it really was, to me, I saw it as training for people throwing data sets at me and trying and figure out what their quirks are, how I can parse interesting file formats or can find maybe statistical issues in them. My PhD really was sort of a boot camp in working with data.
Oh, Patrick, I can't hear you. It looks like you're muted.
Yeah. It was weird. I got dropped for a bit during the PCA, and then
you jumped back in.
Yeah, now I'm back in. You didn't want to stay in the field of computational biology, or?
That's a funny story. So I was actually applying. I was right near the end of my PhD. I was applying for jobs as a postdoc to work in a computational biology lab, and then someone reached out to me from the company Stack Overflow. And I had written a post on Stack Overflow a couple years earlier that explained a statistical concept I was a big fan of, the beta distribution. And someone reached out saying, this is why I love working at Stack Overflow. There are great answers like this about the beta distribution. And then a moment later, he said, by the way, if you want an interview here, you can have one. And 1 month later, I had finished my interviews. I signed an offer with them, and that was my first job as the first data scientist at Stack Overflow. So I was this close to being in biology. But the thing I really learned from that experience is how valuable public work is, how valuable it is to put, explanations like the kind that you do here out there into the world, to put documentation, to put tutorials, to put blog posts, to put ideas. Because you never know how maybe even years later something like that can change your life.
Yeah, what would you say? I mean, I guess I think it's difficult for people to have an appreciation for that. Like, it was super impactful for me to do that a long time ago as well. And one of the things I would always hear from friends is, dude, you're doing so much stuff for free. Like, you're wasting your time. Like, give us some example. I mean, aside from that example, like, it seems like there's been a lot of opportunities. Like, I feel like even just a few months ago, you put on Twitter basically like, hey, I'm a free agent, like, willing to entertain jobs. And all of a sudden, like, all of these people know who you are because it hasn't been a waste of time. You've been giving of your time, and it's paid you back.
That's absolutely true. It was very helpful, not just in people reaching out saying, here, would you be interested in applying to my company, but just having a network of people that knew what kind of thing I'm interested in, had friends in this area, had suggestions of Slack channel to join, people to talk to. It was one of those that I ended up joining Heap, the product analytics company. It wasn't that someone at Heap had read something I'd done and reached out to me the way they had at Stack Overflow. It was that actually someone had just suggested that I join a Slack channel, a private Slack channel that I then where there was a jobs network. And someone there reached out to me and encouraged me to apply to Heap. So it'll always be an interesting process. It's not always going to be clean. Like, okay, yes, everything you do, here's the exact moment that it then pays off for you. It doesn't work like that. But building a network really does have it has long-term benefits. I talk a lot about this in actually I have an RStudio keynote talk from 2019 called "The Unreasonable Effectiveness of Public Work," where I give a lot of examples like this. Let me see, one more example of doing things publicly. Yes, so I was in 2015. There a relatively data scientist. Julia Silke had just started learning R and publishing blog posts about R, and she did some blog posts about sentiment analysis. And she was just getting into the data science space after a career mostly in she had a PhD in astronomy. But she had these really great analyses that then I collaborated with her a little bit on them, and then at a hackathon we worked together to create the TidyX package. And after that, we both basically alternated creating public material based on it, some vignettes for the package, some blog posts that gave examples, and with that we were both expanding the how well the package could work and creating a population of data and of documentation for it. So the thing was, after a couple months of doing that, we had so much material we decided to turn it into a book, and it's now a published book, Text Mining with R, published by O'Reilly. And not everything that I've made public becomes a book. Not everything helped me get a job, but it's a really productive habit to get into.
Mm-hmm. Yeah. Super. All right. Well, looks like we're running out of time here. I just have one question. So what advice would you give to people that are just starting out? I guess two questions. What advice would you give to somebody that's just starting out, and what advice would you give to people that have had a few years now of experience but are looking to make their next steps?
Yeah. So for people that are starting out, I can't recommend strongly enough going into doing some Tidy Tuesday analyses. So I time box myself to an hour. That may not be the pace everyone wants to choose. Some people might want to spend less and make one graph. Some people want to take more and really spend time learning each of the concepts. But it is such great practice to you jump into a data set, you try something, you keep moving, especially if you're not already working in data science and you don't have the opportunity to get those kinds of challenges in your everyday work. I think it's such an amazing project, and it's such a and I'd say it's such a good way to practice those skills. And I'd also say that turning those into a blog is a really good way to leverage that and get feedback, get support from the community, and start building a network. So that's what I'd recommend for people that are just starting out. For people that have more experience, I think there's a lot to be gained. Well, I think there is still a lot to be gained from Tidy Tuesday. I learn a lot from my Tidy Tuesday analyses, but I'd say there's especially something to be gained if there's something you want to learn. If you decide, okay, at this point, I want to learn to make, I'll give an example, is I never used to make a lot of graphs. Didn't come up that often for me in my jobs. And so when I do Tidy Tuesday, Screencast, if I'm making a graph, I'm usually learning something. I might learn to use the leaflet package to make an interactive graph with HTML elements, like in my Tidy Tuesday Volcano screencast. I might make an animated choropleth where I use colors to show change over time, like in my recent Australian animal outcomes screencast. But the story, and in other areas, I want to get what I currently want to get better at is I want to master some of the newest technologies in the Tidy models package. I've been using machine learning from kind of an older generation of tools, and I'd like to get more practice with Tidy models, Tune, Yardstick, and the rest of those packages. So what I do now that I've started trying to work with those is pick a data set that I know I can get a build a machine learning model out of and use those tools. So I'd say like it's worth looking at if there's a technical skill that you want to grow in, or a skill like communication, visualization that you want to grow in. Find something that instead of don't just read blog posts about it. Maybe you can take a course in it. There are ways to learn from that, but nothing, in my opinion, is better than actually doing the thing, taking a data set, practicing that skill. So that's something that at any point of experience someone can learn from.
Gotcha.
That's awesome.
That's super great advice. Thank you very much for joining us today and working through your code to go explain it to people. I guess we'll end it here. Like I said, thank you for joining us. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick.
And I'm Dave Robinson. You can find me on Twitter at drob or on Variance Explained or on my YouTube channel.
All right.
Awesome. Appreciate it.
Keep safe and keep exploring your world.
Thanks for having me.